Now the next part, square root 1 plus x is equal to 1 plus x by 2 minus x square by 8 plus x cube over 16 plus so on. Again the same process, you can easily do yourself. I just write all these values. Given that f of x is equal to square root 1 plus x, just to apply successive derivatives, f prime of x, first derivative, as we already discussed in our previous exercises, that derivative of square root function is just 1 over 2 1 plus x raised to the power minus 1 by 2, and then derivative of 1 plus x, which will become 1. Not need to write f double dash x, or second derivative, applying the power theorem here, 1 by 2, this minus 1 by 2, 1 plus x raised to the power minus 1 by 2 minus 1. And we have this one is minus 1 by 4, 1 plus x raised to the power minus 3 by 2. Third derivative, again using power formula, minus 1 by 4 is as it is, and minus 3 by 2, 1 plus x raised to the power minus 3 by 2 minus 1. So that is actually 3 by 8, 1 plus x raised to the power minus 5 by 2. So put x is equal to 0. In all these derivatives, f of 0 will become 1, f prime of 0, first derivative at x is equal to 0 will become 1 by 2 by calculating this one. As already mentioned, that any power of 1 will become 1. So that will become 1. 1 into 1 by 2 will be 1. F double derivative at x is equal to 0. This leads to the result minus 1 by 4. And third derivative at x is equal to 0, we have 3 by 8. Applying Maclaurin's theorem, write the statement of Maclaurin theorem, which is f of x, f of 0, f prime of 0, f double dash 0, the third derivative, and in denominator 1 factorial, 2 factorial, 3 factorial, multiplying to the term x, x square and x cube up to so on. Just putting the values, f of 0 is 1, which is this one, f prime of 0, 1 by 2, 1 factorial into x, double derivative, which is minus 1 by 4, 2 factorial x square, third derivative 3 by 8, 3 factorial and x cube. So by simplifying, that will become f of x is equal to 1 plus x by 2 minus x by 8 plus x cube by 16, which is our required result. And on left hand side, we can mention it out that this one is square root 1 plus x. So that leads to the required proof. Similarly, fourth part, e raised to the power x is equal to 1 plus x square by 2 factorial and x cube by 3 factorial up to so on. Just take the function f of x is equal to e raised to the power x, then applying derivatives, first derivative remains e raised to the power x, double derivative again e raised to the power x, as the formula of derivative of e raised to the power x is e raised to the power x. So third derivative will remain same. Put x is equal to 0 in all these derivatives and function f of x. So that will become f of 0, which is 1, f of the f first derivative at x is equal to 0, e raised to the power 0, which is 1, double derivative e raised to the power 0, again 1, and third derivative e raised to the power 0, which is 1. Now applying Maclaurin's theorem, f of x is equal to f of 0 plus first derivative at x is equal to 0, 1 factorial x, similarly double derivative x square, 2 factorial, third derivative x cube over 3 factorial. Now just putting the values of all these derivatives and f of 0, which is 1, we have f of 0, f prime of 0, 1, double derivative 1, third derivative 1, and that is our required proof. F of x is equal to 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, and this one is actually a result of e raised to the power x, or this one is Maclaurin's theorem or Maclaurin's series of e raised to the power x. Fifth derivative, almost the same procedure, just we have a power 2x instead of x of e. Solution, given that f of x is equal to e raised to the power 2x. So applying derivatives, e raised to the power 2x will remain e raised to the power 2x, and then derivative of 2x, which is 2. Using a derivative formula of exponential function, which is e raised to the power x, and then applying derivatives on this value, which is 2x, and derivative of 2x will be 2. So we have first derivative 2 e raised to the power 2x. Similarly, double derivative is 2 into e raised to the power 2x, this one, and then derivative of 2x will become 2 totally, or Overall second derivative will become 4 e raised to the power 2x. Similarly, third derivative will become 8 e raised to the power 2x. Put x is equal to 0 in our all these derivatives and f of x. So that will become e raised to the power 0, which is 1. First derivative e raised to the power 0, 1 multiplying by 2 will become 2. Third derivative or second derivative 4 into e raised to the power 0, which is 4. Third derivative e raised to the power 0 multiplying by 8 will become 8. Now applying Maclaurin's theorem, f of x, f0, first derivative at x is equal to 0, 1 factorial, similarly onward. So just putting the values of all these derivatives and f of 0, by simplifying, that will become f of x is equal to 2 over 1 factorial, 4 over 2 factorial, and 8 over x cube, 8 into x cube over 3 factorial, which is actually this required result.